This video covers section 11.2, exponential functions, objective 2, graph exponential functions. Practice 2, using the points found in practice 1, graph the exponential function f of x equals 2 to the x and state the domain and range. Since this is a practice problem, I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. So we want to take this table of values that we found in practice 1 and use those to plot the points on the graph. We have 0, 1. We have 1, 2, 2, 4, and 3, 8. 4 would be at 16, so that's off our graph paper. But then -1 is a half, and -2 is a fourth, and -3 is an eighth, and -4 would be a 16th, and a 32nd, which means it's getting really small, but it never attains the value of 0. It gets large quickly on the right side of the graph because you're doubling every step. But when you take a half of a half of a half of a half of a half, it will never equal 0, but it will be so close to it. We can place any number as an exponent, getting a domain of all real numbers. It's the range that is not all real numbers, because when you raise 2 to any given power, it will always be greater than 0. Our range is from 0 to infinity, not including 0. If you keep cutting something in half, there will always be something there. I like to think of every time I dust my house, I cut the dust in half. I keep cutting the dust in half. At some point, I call it clean enough. It's never 0 dust. There will always be some dust left over. Practice 3. I encourage you to press pause on your video and work this one out. Try to find the difference between the two graphs in practice 2 and practice 3. Press pause on your video and come back when you're ready to see the solution. Now that you've had your chance to work this out, I'll work this out with you. So let's copy and paste the values that we already found, and then we'll plot those on the graph. Zero, 1, 1, 1/2, 2, 1/4, and 3, 1/8. 4 would be 1/16. -1 is at 2, -2 is at 4, and -3 is at 8. As x gets big on this graph, the y values get small. Make sure it never touches the x-axis. The domain is still all real numbers, and the range is still greater than 0. But in comparison, the two graphs, we say that they are reflections, or one is reflected about the y-axis to obtain the other. We call this one growth because it's getting bigger over time. And we call this one decay because it's getting smaller. over time. So we characterize all graphs in which the base is greater than 0 but less than 1 to look like decay. And if the base is greater than 1, its graph will all be displayed by growth. So we state some properties of the graph of exponential functions. A to the x where a is greater than 1. The domain is the set of all real numbers, and the range is the set of all positive real numbers. That's greater than 0. There are no x-intercepts because it doesn't cross the x-axis. It never attains the y value of 0. It's always greater than 0. And the graph contains the points -1, 1 over a, 0, 1, and 1a. -1, 1 over a, 0, 1, and 1a. So if we change it to 2 to the x minus 1, we can still use point plotting. But one thing to keep in mind when graphing these, if the base is greater than 1 and its base is 2, then you're doubling every step. If the base is 1/2, then you're dividing by 2 every step. And so let's get a nice starting point here. And that starting point is always what makes the exponent 0. So let's start with x equal to 1. 2 to the 1 minus 1 is 2 to the 0, which is 1. So this one starts off at 1, comma 1. At 2, we have 2 to the 2 minus 1, which is 2 to the first, or 2. And now we start doubling. 2 to the 3 minus 1 is 2 squared, or 4. 4 is 2 to the 4 minus 1, which is 2 cubed, which is 8. So we saw that we multiplied by 2 each step there, which means on the other side, we're going to then have to divide by 2. Plugging in 0 is 2 to the 0 minus 1, or 2 to the -1, which is 1/2. So now we're just cutting everything into a half to get the graph on the other side. So what you see there is that we shifted the graph over 1 to the right from the original one. The domain is all real numbers. The range is still greater than 0. Here's a practice problem for you to try. Notice that the +1 is on the outside, or not done to the x. It's done to the 2 to the x. So pay attention to what the +1 does to the original graph. Since this is a practice problem, I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. So the value that makes the exponent 0 is 0. That's 2 to the 0 plus 1. That's 1 plus 1, which is 2. We're starting off at 0, 2 this time. Now we're going to start multiplying by 2. 2 to the first plus 1 is 2 plus 1, which is 3. Two squared is 4, plus 1 is 5. So there's where the steps are multiplying by 2. So we went up 1, up 2, up 4. 3 is going to be 2 cubed is 8, plus 1 is going to be 9. Now we divide by 2. -1. So 2 to the -1 plus 1 is 1/2 plus 1, which is 1 1/2. -2 is going to be 2 to the -2 plus 1. 1/4 plus 1 is 1 1/4. And so you see these distances being cut in half now. Cut in another half and a half, and it's always going to stay this time above the line y equals 1. We like to draw an imaginary line there to show this reference line that the graph never gets below that dashed line and never touches it. We say the graph doesn't touch it. So we connect the dots, we get the growth because the base here is 2 on the right side, and the decay this time is on the left side. So make sure your graph never touches that horizontal line. So this time the domain is still all real numbers. This is always a fixture with exponential functions. The domain will always be all real numbers. The range this time has been changed because we lifted the graph up 1. This graph will always be above the y value of 1 and never hit that y value. This is a characteristic of exponential functions. And this concludes the video for section 11.2, Exponential Functions, Objective 2, Graph Exponential Functions.